Welcome to the Structure Analysis 1. In this lecture, we are going to start our new journey of structure analysis. Structure analysis is totally similar and depend on the mechanics of solid, which you already studied, and the syllabus for structural analysis 1 is fundamental of static determinate structure, weightage 25, arches and cable, thin cylinder, strain energy and displacement of statically determinate structure, direct and bending stress plus column and struts, application of direct and bending stress, column and strut, statically indeterminate beam, in which we are studied basics of staticals, properties of prop cantilever beam, fixed beam, continuous beam, and last computer application in structural engineering, which are only for laboratory purpose. Now we are going to start our first lecture, which is fundamentals. Let us see a glimpse of fundamentals, in which we are studying statically determinate and indeterminate structure, degree of redundancy, degree of indeterminacy, advantages and disadvantages of the indeterminate structure, stability of structure, degree of redundancy of beam, degree of redundancy of plane truss, plane frame, grid, press frame, space truss, space grid, etc. Principle of superposition and Maxwell reciprocal theorem. On base of mechanics of solid, we can also solve some examples. Let us directly move on our first chapter. We already discussed about that points. First, statically determinate and indeterminate structure. Determinate structure: the structure for which the reaction at the support and the internal forces in the member can be found out by condition of static equilibrium is called a static determinate structure. There are three basic conditions of static equilibrium: summation of h is equal to 0, summation of v is equal to 0, summation of m is equal to, that indicate horizontal number of force is equal to 0, vertical force number of force is equal to 0, and all the moment which from the all direction are all to 0. Indeterminate structure: the structure for which the reaction at the support and the internal forces in the member cannot be found out by condition of static equilibrium is called static indeterminate structure. There are a similar definition but a little change. Let us revise it. The structure for which the reactions at the support and the internal forces in the member cannot find out by the condition of static equilibrium is called static indeterminate structure. ઉપરની આ ત્રણ condition summation of h, summation of v અને summation of v they જેના equation થી solve થાય તે structure એને determinate structure કહેવાય અને જે આ condition થી solve ના થાય એને indeterminate structure કહેવાય. There are two types of indeterminate or determinate structure, which are externally indeterminate structure or internally indeterminate structure. The structure from which we are not able to find inside forces but find outside, that are internally indeterminate structure, and the vice versa, externally indeterminate structure. What is structure? When any elastic body is subjected to a system of forces and deformation take place and the resistance is set up against the deformation. Then the elastic body is known as structure. If no resistance is set up in the body against the deformation, it is known as a mechanism. That's why the difference between mechanism and structure are vast. Let us discuss again. When an any elastic body is subjected to a system of force and deformation take place and the resistance is set up against the deformation, then the elastic body is known as a structure. If no resistance is set up in the body against the deformation, it is called as a mechanism. Now, main portion, degree of statically indeterminacy. It is also known as d small s. The degree of static indeterminacy of the structure may be defined as the number of unknown force in the axis of equation of static. It is also known as degree of redundancy. That's why in introduction of the chapter I use degree of redundancy in place of degree of static indeterminacy. Now, degree of static indeterminacy. The equation of degree of static indeterminacy is total number of unknown forces minus number of equation of static equilibrium. Number of unknown forces, that means the force which are totally unknown to the structure, and the number of equation of static available is summation of h, summation of v and summation of m. The result is extra unknowns and is called redundant. Redundant may be support, reaction or internal force in the member. If the redundant are removed from the structure, it becomes determinate. Thus, the degree of indeterminacy is equal to the number of release necessary to make the structure determinate. The indeterminacy of a structure may be either external or internal, or maybe both. Let us DSE is equal to degree of external indeterminacy. We know degree of static determinacy indeterminacy means D and S, but the E stand for external and I stand for internal. That's why we put the DS and DE. That's why the equation of ds is equal to dse plus dsi. Now, external static indeterminacy DSE. It is related with the support system of the structure and it is equal to the number of external reaction in excess of number of static equilibrium equation. DSE is equal to R minus R. Small r stand for total number of condition equation available and R stand for total number of external reaction. That's why R minus small r. Capital R is not available because the structure is known and then we can find the what are the force is unknown and what are the force are known. And small r is always fixed for two-dimensional structure is equal to 3 and three-dimensional structure is equal to 3. Because there is a two-dimensional structure, we can only see x, z or x, y or y, z. Rest of the direction are invisible in two dimension. But in the case of three dimension, there are three all dimension are direction are visible. Now Move to the next point, internal static indeterminacy. It refers to the geometric stability of the structure. If, after knowing the external reaction, it is not possible to determine all internal force or internal reaction using equilibrium equation along, then the structure is said to be internally indeterminate. There are a difference between statically determinate structure and statically indeterminate structure. The difference is that conditions of static equilibrium are sufficient to the fully analyze the structure. Conditions of static equilibrium are insufficient to analyze the structure. In this case, the bending moment at the section or the force is any member is independent of the material of the component of the structure. In the indeterminate structure, the bending moment at the section of the force in a member depend upon the material of the component of the structure. Also, the bending moment at a section or the force in any member is independent of the cross-section area of the component, and these are the dependent upon the cross-section area of the. No stress are caused due to lack of fit. Stress are caused due to lack of fit. No stresses are caused due to temperature change. Stress are caused due to temperature change. They are not economical. They are economical. They are flexible. They are rigid. Simply supported beam and cantilever beam are the best example of static determinate structure, and fixed beam and continuous beam are the best example of statically indeterminate structure. Now, advantages and disadvantages of indeterminate structure. Indeterminate structure are become more and more popular day by day because they provide an economical structure as compared to the determinate structure. Economy in indeterminate structure can be explained as follows. Consider two beams, one simply supported, another beam fixed beam, having same span and loaded by same UDL as shown in figure. Let us compare. This is the simply supported beam. This is a fixed by two sides. Then we can say that the force 270 kilonewton into meter here. They are only 19 kilonewton into meter, 180 kilonewton into meter, and 180 kilonewton into meter. Now, through the calculation for simply supported beam, we know the equation of moment for simply supported is WL square by 8 and the for fixed WL square by 12. That we put the values W is equal to 60 kilonewton per meter and the length is equal to 6 meter. We get 270 kilonewton into meter. Similarly, here we get the 19 kilonewton into meter. It can be seen that the indeterminate beam produce the considerable moment to be registered, resulting as a overall economy. But with determinate structure, the cost of creating fixity and support, designing column and foundation for combined axial load and bending moment, etc., increase the cost considerable. However, with the indeterminate structure, total saving of 5 to 8% may be obtained. It's not a big but viable. Let us clear the proper advantages and disadvantages. Saving in material, more rigid structure, better aesthetic structure, and large in span. And the disadvantage is analysis is difficult but obvious. Secondary traces are released, not very that much. Trace reservoir. Now we are complete our session at this point and start our new lecture for the beginning of static stability of structure and some basic information about the loading and disloading joints conditions, degree of redundancy, DS, decay, degree of kinetic indeterminacy, etc. I'm going to stop our session.